Is it screen is visible to us all?
Yes, sir.
Okay. Now we will start the unit number 2, linear differential equation. Linear differential equation with variable coefficient. With variable coefficient. Okay. Now the introduction part. Okay. A linear differential equation, a linear differential equation of order n, of order n with variable coefficient, with variable coefficient is an equation of the form, is an equation of the form a naught of x into y raised to nth derivative plus a1 of x into y raised to n minus 1th derivative plus up to so on plus an of x into y, which is equal to b of x, where where a1 of x, a naught of x, where a naught is not equal to 0. Okay, where a naught of x is not equal to 0, and a1, a2 up to an of x and b, that is b of x, are complex valued functions. Complex valued functions defined on some interval I. Okay. If suppose what happen if a naught is equal to 0? Tell me what happen if a naught is equal to 0?
Linear differential equation in of order n minus 1 येईल.
Okay, very good. If suppose इथे जर तुमचा a naught जर 0 झाला, then this is the linear differential equation of order not n, here the n minus 1, okay, with variable coefficient. That's why we have taken a naught is not equal to 0, and that is a naught means what? A naught of x is not equal to 0. Okay, and a1 of x up to an of x and b of x are the complex valued function defined on some interval I. Okay, understood?
Yes, sir.
Since a naught is non-zero function. Okay, the number नहीं है तो non-zero function. Dividing, therefore, dividing a naught of x or a naught. Okay, dividing by dividing the equation by a naught of x, that is a naught, and we get what we get, the function as assuming the a1 ai of x upon a naught of x is equal to AI of x, okay, as new AI. Okay, this is new AI for I running from 1 to up to n. Okay, AI of x upon a naught of x is equal to new AI. Okay, this is the new AI of x. Thus, thus the above equation becomes y raised to n plus a1 of x into y raised to n minus 1 plus a2 of x into y raised to n minus 2 plus up to so on an of x into y, which is equal to b of x. Okay, and b of x upon a naught of x is nothing but what? New bi of x. Okay, so this is the new equation, and all these a1 a2s are different from this one. हे कशात डिफरंट असणार, ह्याच्यापेक्षा वेगळे असणार, ते न्यू असणार. ओके, डिवाइडिंग बाय ए नॉट ऑफ एक्स फॉर दिस इक्वेशन. Okay, we will denote the left of the expression by L of y. Okay, therefore L of y is nothing but y is to n plus a1 of x into y is to n minus 1 plus a2 of x into y raised to n minus 2 plus up to so on an of x into y. Therefore, L of y is equal to what? B of x. Okay, any doubt up to here?
No, sir.
Now, the next one, homogeneous differential equation. Homogeneous differential equation. If b of x is equal to what? B of x is equal
0.
to 0 for all x belongs to I, that interval I, then we get L of y is equal to y raised to n plus a1 of x into y raised to n minus 1 plus up to so on plus an of x into y, which is equal to 0. It's called homogeneous differential equation with variable constant, okay, of n. Order n. Any doubt up to here?
No, sir.
Now, the second one is non-homogeneous differential equation. Non-homogeneous differential equation. Okay, if b of x is not equal to 0, then we get L of y is equal to b of x is the non-homogeneous differential equation. Okay, if b of x is not equal to 0 for all x belongs to I, then we get L of y is equal to L of y is equal to b of x is of order n. Okay, any doubt?
No, sir.
Now, the next point is existent theorem. Okay, what is the initial value problem for the homogeneous equation? Okay, the next point is initial value problem for the homogeneous equation. Initial value problem for the homogeneous differential equation. And in this, one theorem is there in this point. Which theorem? The existent theorem. Okay, for us, only statement is there. Okay, no, only statement is there for our syllabus, not proof. What is theorem? Let a1, a2, up to so on an be continuous functions on an interval I, okay, on an interval I containing the point x naught, containing the point x naught. Okay, and if alpha 1, alpha 2, up to so on alpha n are any n constant, are any n constants, then there exists, or that is there exists a solution phi of which one? There exists a solution phi. Existence theorem काय सांगतोय? ते एक इनिशियल व्हॅल्यू प्रॉब्लेमला एक एक्झिस्ट होते phi हा सोल्युशन. There exists a solution phi of L of y is equal to y raised to n plus a1 y raised to n minus 1 plus a2. Okay, a1 म्हणजे काय ते a1 of x. Okay, not a1 of x into y raised to n minus 1 plus a2 of x into y raised to n minus 2 plus up to so on an of x y raised to nothing. Okay, which is equal to 0. There exists a solution for L of y is equal to 0 on I satisfying phi of x naught is equal to alpha 1, phi dash of x naught is equal to alpha 2, up to so on phi raised to n minus 1 of x naught is equal to alpha n. Okay, so this is the existent theorem for the Okay, connection तुटला होता. Okay, this is the existence theorem. Let a1, a2, and up to so on an. Wait a minute. Wait a minute now. Okay, is it visible?
Yes, sir.
Yes, sir.
Yes, sir.
Let a1, a2 up to an be the continuous functions on an interval I containing the point x naught. If alpha 1, alpha 2 up to so on alpha n are any n constants, then there exists a solution phi of L of y is equal to 0, satisfying phi of x naught is equal to alpha 1, phi dash of x naught is equal to alpha 2 up to so on, phi dash to n minus 1 of x naught is equal to alpha n. Okay, आपल्याला याचं फक्त स्टेटमेंट आहे, नॉट प्रूफ. Okay, now the next theorem is let b1, b2 up to so on bn be non-negative constants such that for all x belongs to I, this function ai of x, okay, mod of ai of x is less than or equal to bi. Okay, for all x belongs to I, for I running from 1 to up to n. What it means? This ai of x is the function. Okay, these are the variable. म्हणजे काय ते variable constant म्हणजे काय ते ai of x, all these a1 of x, a2 of x, an of x, these are the functions of x. Okay, so what is the meaning of this one? Mod of ai of x is less than or equal to bi, where this bi is non-negative constant. याचा अर्थ काय? आवाज ऐकू येतोय का?
Yes,
Yes,
sir.
sir.
Yes, sir.
तुमचा ai of x हा काय? Mod of ai of x is less than or equal to bi. याचा अर्थ काय? Mod of x is less than a. याचा अर्थ काय? x is in between a and minus a, हो ना?
Yes, sir.
म्हणजे काय x हा तुमचा काय बाउंडेड आहे इन बिटवीन मायनस ए टू ए.
Plus A.
ओके, आता हा तुमचा फंक्शन आहे, ह्याचा फंक्शनचा अर्थ काय? हा मॉड ऑफ ए आय ऑफ एक्स इज लेस देन ऑर इक्वल टू बी आय. एखादा फंक्शन बाउंडेड असेल तर काय करतो आपण? एफ ऑफ एक्स, मॉड ऑफ एफ ऑफ एक्स इज लेस देन ए, हो ना? कळते का?
Yes, sir.
Here we have mod of ai of x is less than or equal to bi. हा bi काय तुमचा नॉन निगेटिव्ह कॉन्स्टंट आहे कोणता? Okay, it means that all functions ai of x, a1 of x, a2 of x, a3 of x are bounded functions. Okay, कळते का?
Yes, sir.
Oh, sir.
Okay, तेच विचारलं. So let b1, b2, bn be the non-negative constant such that for all x belongs to I, mod of ai of x is less than or equal to bi for I running from 1 to n. Okay, and define k is equal to 1 plus b1 plus b2 plus up to so on bn. Okay, and if x naught is any point in I, is any point in I, and pi is solution of L of y is equal to 0 on I, then same statement which we proved in the previous unit. What is norm of pi of x naught into e raised to minus k to mod of x minus x naught, which is less than or equal to mod of norm of pi of x, is less than or equal to norm of phi of x naught into e raised to k into mod of x minus x naught. We have to prove this one for all x belongs to I, where norm of x is what? Kind of norm of x, mod of phi of x bracket square plus mod of phi dash of x bracket whole mod square up to so on mod of phi raised to n minus 1 of x bracket square whole bracket raised to 1 by 2. ओके, सेम थेरम आहे जो मागच्या युनिटला आपण प्रूव्ह केलेला आहे. इथे फक्त काय येणार, के ची व्हॅल्यू चेंज होणार. ओके, 1 प्लस b1 प्लस b2 अप टू सो ऑन bn. ओके, आणि एल ऑफ वाय काय तुमचा होमोजिनियस डिफरन्शियल इक्वेशन, होमोजिनियस लिनियर डिफरन्शियल इक्वेशन विथ व्हेरिएबल कोएफिशिएंट. ओके, एनी डाऊट इन द स्टेटमेंट?
No, sir.
तुम्हाला एक्झामला दिल्यानंतर दिलेला इक्वेशन एल ऑफ वाय नीट चेक करा काय. ओके, सेकंड ऑर्डर आहे, सेकंड ऑर्डर होमोजिनियस आहे की सेकंड ऑर्डर नॉन होमोजिनियस आहे, nth ऑर्डर होमोजिनियस आहे का nth ऑर्डर नॉन होमोजिनियस आहे का, nth ऑर्डर होमोजिनियस विथ व्हेरिएबल कोएफिशिएंट दिलेला आहे, हे नीट चेक करा. ओके, नाउ प्रूफ. Let u of x is equal to norm of phi of x bracket square, which is equal to mod of phi of x plus bracket square mod square of phi dash of x plus up to so on mod square of phi raised to n minus 1 of x. Okay, which is equal to phi into phi dash plus phi bar, sorry, phi dash into phi dash bar plus up to so on plus phi raised to n minus 1 into phi raised to n minus 1 bar. Why we can write like this? Because mod of z square is equal to z into z bar. Okay, any doubt up to here?
No, sir.
Now differentiate. We get differentiate with respect to x. We get u dash of x. Okay, u means u dash of x, which is equal to first as it is derivative of second plus second as it is derivative of first plus phi dash into phi double dash bar plus phi double dash into phi dash bar up to so on plus phi raised to n minus 1 as it is phi raised to n bar plus phi raised to n into phi raised to n minus 1 bar. Okay, any doubt up to here?
No, sir.
चुकत असेल तर सांगा मला. ओके, कॅल्क्युलेशन पार्ट आहे सर. नाउ टेकिंग मॉड्युलस ऑन बोथ साइड्स, taking modulus on both sides, we get mod of u dash of x is equal to, okay, mod of u dash of x is equal to, wait a minute, mod of in the bracket phi into phi dash of plus phi bar into phi dash plus phi dash into phi double dash bar plus phi double dash into phi dash of bar plus up to so on plus phi raised to n minus 1 into phi raised to n bar plus. Okay, any doubt up to here?
No, sir.
Which is less than or equal to mod of phi into mod of phi dash bar plus mod of phi bar into mod of phi dash plus mod of phi dash into mod of phi double dash plus mod of phi double dash into mod of phi dash bar plus up to so on plus mod of phi raised to n minus 1 into mod of phi raised to n bar plus mod of phi raised to n into mod of phi raised to n minus 1 bar. Okay, any doubt? We have
No,
mod
sir.
of a plus b, which is since reason guy less than or equal to mod of a plus mod of b. Okay, which is less than or equal to mod of phi into mod of phi dash plus, okay, using this result now, mod of z is equal to mod of z bar. Using this result we can write instead of this one mod of phi dash plus phi into mod of phi dash plus the bar है ना phi dash into mod of phi double dash plus mod of phi double dash into mod of phi dash plus up to so on mod of phi raised to n minus 1 into mod of phi raised to n plus mod of phi raised to n into mod of phi raised to n minus 1. Okay, any doubt up to here?
No, sir.
Which is less than or equal to solve करत चला तसेच 2 times mod of phi into phi dash plus 2 times mod of phi dash into mod of phi double dash up to so on plus 2 times into mod of phi raised to n minus 1 into mod of phi raised to n minus, sorry, n. Okay, any doubt up to here? Give it as an
No,
equation
sir.
number
No, sir.
2. Okay, equation 1 कशाला द्यायचं? Give this and an equation number 1. Okay, equation number 1, this is the equation number 2. Okay, now we have, since phi is the solution of L of y, since phi is the solution of L of y, okay, is equal to 0. It implies that phi raised to n is equal to minus a1 into phi raised to n minus 1 plus a2 of x into phi raised to n minus 2 plus up to so on an into y. Okay, any doubt? Directly let's go. Okay, again taking modulus on both sides, which implies mod of phi raised to n, which implies mod of a1 into less than or equal to mod of phi raised to n minus 1 plus mod of a2 into mod of phi raised to n minus 2 plus up to so on plus mod of an into mod of, okay, this is the phi, no? This is phi. Okay, any doubt up to here?
No, sir.
Now we have what we have, mod of ai of x is less than or equal to bi for all x belongs to I and I running from 1 to up to n. So instead of here ai of x, a1 म्हणजे काय, ai of x, instead of a1 we can write b1 instead of b2. ओके, ह्याच्यापेक्षा ही मोठी क्वांटिटी आहे b1 तुमची, a1 पेक्षा कोण, b1 मोठा आहे तुमचा. So instead of we can write a1 here the b1, so there is no effect on this inequality sign. Okay, so hence we can write, it implies that mod of phi raised to n is less than or equal to b1 into b1 into mod of phi raised to n minus 1 plus b2 into mod of phi raised to n minus 2 into plus up to so on. This is bn into mod phi. Okay, any doubt up to here?
No, sir.
ओके, इन्स्टेड ऑफ A1 वी कॅन राईट B1. ह्याच्यापेक्षा मोठी क्वांटिटी लिहिली ना आपण. समजा इथे 3 आहे, इथे 3 आहे, समजा B 5 आहे, तर मी ते इथे 5 लिहिलो, तर ह्या इक्वेलिटीवर काय साईन चेंज होणार का? काहीच नाही होणार इफेक्ट. ओके, hence the inequality becomes, now putting this value in equation 2, putting the value of 5 raised to n, mod of 5 raised to n, this value in equation number 2 here, इथे ठेवायचे आपल्याला. कुठे? So we get inequality 2 becomes, inequality 2 becomes, okay, mod of u dash of x is less than or equal to 2 times mod of phi into mod of phi dash plus 2 times mod of phi dash into mod of phi double dash plus up to so on plus 2 times mod of phi raised to n minus 1 into, ओके, आता नीट लक्ष द्या, इथे काय येणार, इंटू ब्रॅकेट B1 into mod of phi raised to n minus 1 plus B2 into mod of phi raised to n minus 2 up to so on. This is Bn into mod of phi. Okay, any doubt?
No, sir.
Which is equal to, which is less than or equal to 2 times mod of phi into mod of phi dash plus 2 times mod of phi dash into mod of phi double dash into up to so on plus into bracket, okay, 2 into, this is B1 into mod of phi raised to n minus 1 bracket square, okay, plus B2 into 2 times mod of phi raised to n minus 1 into phi raised to n minus 2. Okay, any doubt?
No, sir.
B3 into 2 times mod of phi raised to n minus 1 into mod of phi raised to n minus 3 up to so on plus Bn into bracket 2 raised to mod of phi raised to n minus 1 into phi raised to n minus 1 is nothing but 5. ते 3 असताना ते किती येतोय? 3 येतोय ना. phi raised to n minus 1 काय येणार? 0. So 5. Okay, any doubt?
No, sir.
We know that 2 into mod b into mod c is less than or equal to mod b square plus mod c square. Okay, so hence mod of u dash of x is less than or equal to, instead of this one we can write mod of pi square plus mod of pi dash square, okay, plus mod of pi dash square plus mod of pi double dash square, okay, this bracket completes, plus up to so on b1, this is as it is, and 2 times mod of pi raised to n minus 1 bracket square, okay, this term as it is in, okay, plus b2 into bracket pi raised to n minus 1 bracket square plus pi mod of pi raised to n minus 2 bracket raised to square, mod square, okay, plus b3 into bracket mod of pi raised to, आधी ही टर्म लिहूयात, n minus 3 square plus mod of pi raised to n minus 1 square, okay, plus up to so on bn into mod of phi square plus mod of phi raised to n minus 1 square. Okay, understood?
Yes, sir.
काही चुकलंय का माझं? नाही ना? So collecting the terms involving mod of pi square, mod of pi dash of square up to so on, mod of phi raised to n minus 1 bracket square, we get mod of u dash of x is less than or equal to. Now, actually 1 plus bn, इथे तुमचा bn कोएफिशिएंट आहे आणि इकडे phi. So we taken 1 plus bn in one bracket and mod of phi square. Okay, plus this is phi dash square, this is phi dash square. Okay, so here we get the bracket 2 plus bn minus 1. याच्या आधीच्या टर्ममध्ये काय असणार? bn minus 1 च्या phi dash ची टर्म असणार तिथे. bn minus 1 into this bracket is complete into pi dash of mod of pi dash square. Okay, any doubt? Plus 2 into bn minus 2 in one bracket into mod of phi double dash mod of phi double dash square. Okay, any doubt up to here?
No, sir.
अशा शेवटपर्यंत येणार कुठपर्यंत? प्लस अप टू सो ऑन प्लस इंटू लास्ट ब्रॅकेट मध्ये काय येणार बघा 2b1 plus b2 plus b3 up to so on plus bn into mod of phi raised to n minus 1 bracket square. Okay, याच्यातनं b1 येणार 2b1 इथे आला तुमचा 2b1. ओके, b2 कुठे येणार? हा 2b2 हा b3 up to so on bn. This bn is added this and mod of phi raised to n minus 1 bracket. Okay, any doubt?
No, sir.
Now look at here. Since 1 plus bn, okay, all bi's are the positive, okay, non-negative quantities, which is less than or equal to 1 plus b1 plus b2 plus up to so on bn. Okay, या 1 plus b1 मध्ये काय ऍड केलंय? 1 plus bn मध्ये b1 b2 नॉन निगेटिव्ह इंटिजर्स आपण काय केलेत? नॉन निगेटिव्ह नंबर्स कॉन्स्टंट ऍड केलेत. So we get 1 plus bn is less than or equal to 1 plus b1 plus b2 up to so on bn. Okay, so adding some positive terms in the right hand side. Okay, ह्याच्या या स्टेटमेंट मध्ये काय डाऊट आहे का?
No, sir.
सो इथे सगळे बी आहे तुमचे काय नॉन निगेटिव्ह आहे. सो ऍडिंग some positive terms in right hand side of above equation, above inequality in order to convert the coefficient of each term to 2k. Okay, का ऍड करतोय? Because we have to convert the coefficient of each term is 2k. So hence we get mod of u dash of x is less than or equal to, okay, ही टर्म काय येणार? 1 plus b1 plus b2 up to bn ह्याच्यामध्ये कन्वर्ट करायचे. सो 1 plus b1 plus b2 up to bn काय हे टर्म? k. Okay, so this is the k. So here we get 2 into k into mod of phi square plus 2 into k into mod of phi dash of square. Okay, any doubt? काय डाऊट आहेत का? या टर्मला मी कन्वर्ट केलंय कशामध्ये 2k मध्ये. या टर्मला मी कशामध्ये कन्वर्ट केलंय 2k मध्ये बाय ऍडिंग सम पॉझिटिव्ह टर्म्स. या टर्मला काय केलंय ऍड केलंय काही नॉन निगेटिव्ह टर्म्स. सो देर इज नो इफेक्ट ऑन दिस इनइक्वालिटी साइन. Okay, so here we get 2k into up to so on plus 2 into k into what mod of phi raised to n minus 1 bracket square, which is less than or equal to, take 2k common in the bracket, mod of phi square plus mod of phi dash of square plus up to so on mod of phi raised to n minus 1 bracket square, which is less than or equal to 2 k into norm of phi of x bracket square. Okay, so this is the mod of u dash of x. But what is mod of u dash of x? What is the definition? It implies minus 2k into norm of phi of x is less than or equal to u dash of x, which is less than or equal to 2 into k into norm of phi of x. Okay, any doubt?
No, sir.
Give it as an equation number 3. Now again consider the right half inequality. The right half of inequality 3. Inequality number 3. So what we get? That is u dash of x is less than or equal to 2 into k to norm of phi of x. Okay, which implies u dash of x is less than or equal to 2 into k. What is phi of x? Norm of phi of x is nothing but what? U of x. Okay, he अजून केले first. So it implies कुठे इथे u of x is what? Norm of phi of x bracket square. Wait a minute, okay. एकच मिनिट थांब. Correct. Square. इथे तुमचं स्क्वेअर आहे ना. Okay, any doubt? Square आहे सांगत आम्हाला पण. So this is u of x. What it implies? U dash of x upon u of x is less than or equal to 2k. Okay, now case number 1. If x is greater than x naught, then integrating from x naught to x. So we get this is x naught to x, u dash of x upon u of x dx, which is less than or equal to integrating x naught to x. This is the constant 2 into k into dx. Okay, so what is the integration of this side?
Log of u of x.
Log of u of x or u of t, काही घ्या variable. Okay, from x naught to x, which is less than or equal to 2 into k in the bracket x minus x naught, which implies log of u of x upon u of x naught is less than or equal to 2k into x minus x naught. Okay, this implies e raised to 2k u of x upon u of x naught, which is less than or equal to e raised to 2 into k into bracket x minus x naught, which implies u of x is less than or equal to u of x naught into e raised to 2k bracket x minus x naught. Okay, give it as an equation number 5. Okay, similarly taking the left half inequality. Similarly, taking the left half inequality implies we get u of x naught into e raised to minus 2k of x minus x naught, which is less than or equal to u of x. This is the equation number 6. So from 5 and 6 we get u of x naught into e raised to minus 2k in the bracket x minus x naught, which is less than or equal to u of x, which is less than or equal to u of x into e raised to 2k in the bracket x minus x naught. Okay, any doubt up to here?
No, sir.
this सॉल्व करायचं आहे आपण. ओके, हे आधी झालेलंच आहे आपल्याला. नाव केस नंबर 2. What is case 2? If x naught is greater than x, it implies x naught minus x is greater than 0. Okay, so here we get, similarly we get u of x naught, we get similarly we get u of x naught into e raised to minus 2k into bracket x naught minus x, which is less than or equal to u of x, is less than or equal to u of x naught into e raised to 2k into bracket x naught minus x. Okay, but what is u of x? X naught is norm of pi of x naught bracket square e raised to minus 2k. Okay, आदि हे करा from, this is equation number 8. So combining 7 and 8, combining equation 7 and 8, we get u of x naught into e raised to minus 2k into mod of x minus x naught, which is less than or equal to u of x, which is less than or equal to u of x naught into e raised to 2k into mod of x minus x naught. Okay, any doubt up to here? काही डाऊट असतील तर विचारू शकता बरं का. So what is the u of x? It implies norm of phi of x naught, this is the value of square, into e raised to minus 2k mod of x minus x naught, less than or equal to norm of phi of x brackets norm square, which is less than or equal to norm square of phi of x naught into e raised to plus 2k mod of x minus x naught. Now taking square root on both sides. Now taking square root, we get what we get, mod of norm of phi of x naught into e raised to k into x minus x naught, which is less than or equal to norm of phi of x, which is less than or equal to norm of phi of x naught into e raised to k into bracket mod of x minus x naught for all x belongs to I. Okay, any doubt?
No, sir.
काही डाऊट असतील तर विचारू शकता. लिहून घेताय ना, त्यावेळेस लिहून घेत चला. ओके, म्हणजे हाताखालून जाईल. ओके, now take the example.
सर केस फर्स्ट मधलं रायटिंग राहिले.
Okay. हे का? हेच का? हे का?
Yes, sir.
ओके, लिहा देऊन घे. काहीच वेगळं नाही, हे आपण मागं 2दा-3दा प्रूव्ह केलंय. ओके,
झाले, sir.
okay. Now take the example. Consider example number 1. Consider the equation y double dash plus 1 upon x into y dash minus 1 upon x square into y, which is equal to 0. Okay, for x greater than 0. Interval काय दिला तुमचा? X is the positive integers. Okay, now first one, show that there is a solution. There is a solution of the form x raised to r. Okay, where r is constant. Where r is constant. Okay, B. Find two linearly independent solution. Find two linearly independent solution for x greater than 0. Okay, x greater than 0, and prove that they are linearly independent. दोन सोल्युशन फाइंड आउट करायचे आहेत आणि ते लिनियरली इंडिपेंडेंट आहे ते दाखवायचे आहेत. अँड सी, फाइंड दी टू solutions satisfying the condition phi of 1 is equal to 1 and phi dash of 1 is equal to 0. This one condition, and psi of 1 is equal to 0 and psi dash of 1 is equal to 1. Okay, write down these examples. Okay, झाला example लिहून?
हो सर.
Wait a minute. Okay, now solve. Solution. Let, what is the given equation? Y double dash plus 1 upon x into y dash minus 1 upon x square into y is equal to 0. A part, okay, A part 1. Give it as an equation number 1. Okay, we have to prove that. To prove that the solution is of the form x raised to r. The solution is of the form x raised to r, na? That is, phi is the solution which is in the form of x raised to r, where r is constant. Now put x raised to r in equation number 1. So what we get? X raised to r double dash plus 1 upon x into x raised to r bracket dash minus 1 upon x square into bracket x raised to r. Okay, which is equal to 0. What it implies? काय आणायचं डेरिव्हेटिव्ह? r into r minus 1 into x raised to r minus 2. Is it correct?
Yes,
Plus
sir.
1
Yes, sir.
upon x. Correct है ना? हाँ. So r into x raised to r minus 1. Okay, minus 1 upon x square into x raised to r, which is equal to 0. Okay, any doubt?
No, sir.
Implies r into r minus 1 into x raised to r minus 2 plus this is r into x raised to r minus 2 plus this is x raised to r minus 2, which is equal to 0, which implies r into r minus 1 plus r plus 1, okay, into x raised to r minus 2, which is equal to 0, which implies r square minus r plus 1.
Sir,
हाँ
minus
तर
1
ते
आहे sir.
मायनस साईन यायला पाहिजे.
कुठे? हाँ इथे सॉरी minus sign. Minus, okay, so this minus r, this plus r get cancelled. Okay, so here we get इथे minus यायला पाहिजे ना इथे पण r square minus 1 into x raised to r minus 2, which is equal to 0. But we have, since we have x is greater than 0, it implies x raised to r minus 2 is not equal to 0. It implies r square minus 1 is equal to what? 0. Okay, so which is quadratic equation in R. Okay, हा काय येत नाही कळलं 0 because x is the positive, तुम्हाला दिलेलं आहे तिथे इंटरवल x is greater than 0, so hence this is not equal to 0. So we have must r square minus 1 is equal to 0, which is quadratic equation in R. Okay, now corresponding two roots are R1 and R2. Okay, काहीतरी येतील ते. Okay, it implies that phi of x is equal to x raised to r is the nature. त्याच्यावरनं काय कळालं तुम्हाला? अशा इक्वेशनचं सोल्युशन काय असणार? is in the form of x raised to r is the nature of solution of 1. ओके, जर तुमचा इथे क्वाड्रॅटिक इक्वेशन इन आर येत असेल तर हा काय असणार तुमचा नेचर ऑफ दिस टाइप ऑफ इक्वेशन. Nature of solution of this equation must be is in the form of x raised to r, where r is any constant. Okay, any doubt up to here?
No, sir.
Okay, now the second part, B part. Consider what we have to find the two linearly independent solution for x greater than 0 and prove that they are linearly independent. Now consider r square minus 1 is equal to 0. What it implies? R is equal to
1 and minus 1.
plus minus I. Is it correct? Plus minus I येणार का plus minus 1 येणार?
Plus
minus
minus
one
1
येणार,
येणार sir.
Plus minus 1 येणार because r square is equal to 1 is equal to r is implies plus minus 1. So r1 is what? 1 and r2 is minus 1. So phi 1 of x is equal to x raised to r1, which is equal to x raised to 1, which is equal to x. and phi2 of x is equal to x raised to r2, which is equal to x raised to minus 1, which is equal to 1 upon x. Okay, so these are the two solutions, phi 1 and phi 2. And we have to prove that these phi 1 and phi 2 are linearly independent solution. Okay, now to prove that phi 1 and phi 2 are linearly independent. Okay, for let C1 and C2 be any constant such that C1 phi 1 of x plus C2 phi 2 of x is equal to 0. Okay, that is C1 into x, which is phi 1 of x, plus C2 upon x, which is equal to 0. Okay, now we have to prove that this phi 1 and phi 2 is linearly independent. Okay, याचे दोन मेथड आहेत सॉल्व करायचे. Suppose this is equation number 2. Okay, equation 1 दिलेलं आहे. So this is equation 2. Now differentiate. दोन मेथड कोणकोणते आहेत सांगतो. पहिला आधी फर्स्ट मेथड सांगतो. Differentiate with respect to x. Differentiate with respect to x. So what we get here? C1, okay, minus C2 of x square, which is equal to 0. Give it as an equation number 3. Now again differentiate with respect to x. Again differentiate with respect to x. We get what we get? 2c2 upon x cube, which is equal to 0. Okay, but we have x is greater than 0. It implies c2 must be equal to 0. Now putting the value c2 in equation number 3, so what we get here? C1 must be also 0. Hence the two solutions phi 1 and phi 2 are linearly independent. Okay, it implies phi 1 and phi 2 are linearly independent. ही एक मेथड झाली. किंवा अजून एक मेथड काय असणार?
Wronskian.
हां, ते सांगतो. If phi 1 and phi 2, we have to prove that phi 1 and phi 2 is linearly independent solution for what? X is greater than 0. Okay, now put x is equal to 1, which is greater than 0. So what we get here? C1 plus C2 is equal to 0. And इथे ठेवल्यानंतर काय होणार? C1 minus C2 is equal to 0. Now solve this equation. What we get? C1 is equal to C2 is equal to 0. Okay, एका पॉइंटला जरी तो नॉन इक्वल टू एक हाला C1 C2 चा होल काय असणार? दा x greater than 0 ला काय असणार? तो linearly independent. Okay, any doubt?
No, sir.
No, sir.
ओके, कोणताही एक पॉईंट घ्या x ग्रेटर दॅन 0 असेल, तो पॉईंट इथे ठेवा, पॉईंट पुट करा. इथे काय येणार मग? C1 plus C2 is equal to 0 and here we get C1 minus C2 is equal to 0. Okay, now solving these two equations we get C1 is equal to C2 is equal to 0. Hence the phi 1 and phi 2 are the linearly independent solution. Now the C part. Let phi of x is equal to capital A into phi 1 of x plus capital B into phi 2 of x. Hence phi of x is equal to A into x plus B upon x. And we here differentiating with respect to x, we get phi dash of x is equal to A minus capital B of x square upon x square. Okay, now phi of 1 is equal to 1. It implies first condition काय दिले तुम्हाला? Phi of 1 is equal to 1 and phi dash of 1 is equal to 0. Now phi of 1 is equal to 1. It implies that A plus b is equal to 1 and phi dash of 1 is equal to 0. It implies a minus b is equal to 0. So this is equation number कितने आते equation 4 and 5. Okay, it is equation number 4 and this is 5. Now solving 4 and 5. What are the values of a and b? Solving 4 and 5. We get
A equal to 1 by 2, B equal to minus 1 by 2.
b is equal to minus 1 by 2. It implies phi
B
of
equal
x.
to 1 by 2, sir.
1 by 2 च घेतलं की मग. Okay, sorry sir, 1 by 2 येणार ना. B is equal to 1 by 2. So here we get pi of x is equal to x upon 2 plus 1 upon 2x. Okay, so this is the phi of x satisfying the initial condition phi of 1 is equal to 1 and phi dash of 1 is equal to 0. Now the second part. Now psi of x is equal to c into bracket x into capital D upon x, and psi dash of x is implies c minus d upon x square. Now psi of 1 is equal to 0. What it implies? C plus d is equal to 0. And psi dash of 1 is equal to 1. What it implies? C minus d is equal to 1. Okay, now solving these two equations, 6 and 7. Solving 6 and 7, we get c is equal to 1 by 2 and d is equal to 1 by 2. Okay, it implies psi of x is equal to x upon 2 minus 1 upon 2x. Okay, so this is the solution for the D1 differential equation satisfying psi of x is psi of 1 is equal to 0 and psi dash of 1 is equal to 1. Okay, any doubt up to here?
No, sir.
Now, example number 2. Okay, find two linearly independent solution of equation 3x minus 1 bracket square y double dash plus 9x minus 3 into y dash minus 9y is equal to 0. Find the two linearly independent solution. फक्त तुम्हाला फाय काढायचे आहेत. सॉल्व केलंय बीएससी ला. ओके, व्हेरिएबल कॉन्स्टंट असेल तर कसं सॉल्व करायचं शिकलाय ना. कसं करणार सॉल्व? गिवन then. What is given? 3x minus 1 bracket square into y double dash plus 9x minus 3 into y dash minus 9y is equal to 0. Give it as an equation number 1. Now put, what we have to put? 3x minus 1 is equal to t. Okay, so differentiate with respect to t here. Okay, so here we get dt is equal to what? 3 dx. Differentiate with respect to x. Okay, sorry. Here we get 3 into dx by dt is equal to 1, which implies dt is equal to 3 dx. Okay, implies dt by dx is equal to 3. Any doubt up to here? Okay, now using chain rule, dy by dx, we can write dy by dt into dt by dx. Okay, dt dt ऐसे cancel नहीं होती थी. Using chain rule अपन y is the function of t and t is the function of x. Okay, y is the function of x here, and here the t is the function of what? X. Hence dy by dx we can write dy by dt into dt by dx. So what is dy by dt? Dt by dx is 3. Okay, into dy by dt, and denote this is y dot. 3 into this term is, okay, 3 into y dot, which implies dy by dx is equal to 3 into y dot. Okay, any doubt? Any doubt आहेत का?
No, sir.
Okay. Now the next one is d2y by dx square is equal to d by dx of dy by dx. Okay, which is equal to wait a minute. D by dx of dy by dx, na? Okay. This is d by dx of 3 into y dot. Okay, now putting y dot is what? dy by dt. Okay, so which is equal to, now differentiate with respect to x, but this is first we have to differentiate with respect to t and t with respect to x. So here we get d by dt of 3 into dy by dt, okay, into dt by dx. Any doubt? त्याला इंटू आहे पुढे बरं का, त्याला डिफरेन्शिएट विथ रिस्पेक्ट टू एक्स करायचं आहे, बट first we have to differentiate with respect to t and t with respect to x by using chain rule. So here we get d2y by dx square, which is equal to here d by dt of 3 into dy by dt into what is the value of this one is 3. Okay, so which is equal to 9 into d2y by dt square, which is equal to 9 into y double dot. Okay, any doubt?
No, sir.
Okay, now putting these values in equation 1. Okay, so putting these values BSc ला solve केलेलं आहे आपण, putting these values in equation 1. So here we get what we get, 3x minus 1 bracket square, which implies t square. Okay, so this is t square. So d2y by dx is nothing but what? 9 into d2y by dt square. Okay, plus 3 into 3. Okay, this is what? That 3 common काढा, काय येणार? 3 into 3x minus 1. 3x minus 1 म्हणजे काय येणार तुमचा? t येणार. आणि अजून एक t कुठून आला? 3 कुठून आला अजून एक? y डॅशचा. Okay, so this is dy by dt. Okay, minus 9y, which is equal to 0, which implies t square into 9 into y double dot plus 9 into t into y dot minus 9 into y is equal to 0, which implies 9 taking common, so t square into y double dot plus t into y dot plus y minus y is equal to 0, which implies, what it implies? T square into y double dot plus t into y dot minus y, which is equal to 0. Okay, any doubt up to here? Kai samajhte na? Which implies
Yes,
y
sir.
double dot plus y dot upon t minus y upon t square, which is equal to 0. रिड्यूस झाला का मागच्या फॉर्म मध्ये? Okay, it implies y is equal to t raised to r be the solution of above equation. Okay, which implies, by previous example, what we have, r into r minus 1 into t raised to r minus 2 plus r into t raised to r minus 1 upon t minus t raised to r upon t raised t square is equal to 0. Okay, so it implies, by previous example सॉल्व करायचं हे असं कळते ना काय चालू आहे?
हो सर.
r square minus 1 सॉल्व करते असं कसं into t raised to r minus 2 ना is equal to 0. r minus 2 and r minus 1, r minus 2. Okay, it implies, but t raised to r minus 2 never 0. It implies t raised to r minus 1 is equal to 0, which implies r is equal to plus minus 1. So what is phi of t? Phi 1 of t is what? T raised to 1, and phi 2 of t is equal to 1 upon t. Okay, which implies phi 1 of x is, what is t? 3x minus 1. And what is phi 2 of t? Phi 2 of x, 1 upon 3x minus 1. Okay, which is required solution. Okay, any doubt?
No, sir.
Linearly independent prove कर चल. c1 into phi 1 plus c2 into phi 2 is equal to 0 घ्या, differentiate करा. Okay, prove करायचं ना. Find the two linearly independent solution. Okay, prove वगैरे काही करायचं नाही. दिलेलं सोल्युशन लिनियरली इंडिपेंडेंट असतं. ओके, एनी सोल्युशन ऑफ एनी टू सोल्युशन्स काय असतात ते ऑलवेज लिनियरली इंडिपेंडेंट असतात. phi 1 and phi 2 always linearly independent. Okay, any doubt up to here?
No, sir.
Okay, एक theorem बघूया. Uniqueness theorem for the initial value problem. थांबूया. Okay, now the next theorem, uniqueness theorem for the initial value problem. Uniqueness theorem for initial value problem. Okay. Let x naught be a point in I, and alpha 1, alpha 2, up to so on alpha n, any n constants, or any n constants. There is at most one solution phi. Okay, there is at most one solution phi of x, that is phi on I, satisfying the conditions phi of x naught is equal to alpha 1, phi dash of x naught is equal to alpha 2 up to so on phi raised to n minus 1 of x naught is equal to alpha n. Okay, now look at the proof. Let x be the any point in I. Let x be any point in I. Okay, other than x naught. Let x be the point in I other than x naught. Other than x naught, let I be closed and bounded interval in I. Let I be closed and bounded interval in wait a minute. Let I be the closed and bounded interval. Okay, sorry. Let J be the bounded interval. J हा तुमचा I हा any interval आहे ना. Let J be the any closed and bounded interval in I. Okay, containing x naught and x. In this J we have point x naught and x. On the interval J, on the interval J, continuous functions, continuous functions ai of x are bounded. ओके, काय सांगतोय तुमचा हा स्टेटमेंट? जर एखादा क्लोज्ड आणि बाउंडेड इंटरवल असेल, ओके, लुक एट हियर, तुमचा कोणताही क्लोज्ड आणि बाउंडेड इंटरवल जर असेल तर त्या बाउंडेड आणि क्लोज्ड इंटरवल तुमचा जर फंक्शन कंटिन्युअस असेल तर तो फंक्शन पण काय असतो? बाउंडेड असतो. ओके, एव्हरी कंटिन्युअस फंक्शन ऑन क्लोज्ड अँड बाउंडेड इंटरवल आर ऑलवेज बाउंडेड. ओके, तुमच्याकडे एक थेरम आहे. every closed every continuous function on closed and bounded intervals must be bounded. So here the ai of x is the continuous functions, hence the continuous functions on closed and bounded interval j is always bounded. That is, by the definition of boundedness, ai of x, mod of ai of x is less than or equal to bi. Okay, where I running from 1 to up to n. Okay, where bi is non-negative constant. Okay, any doubt up to here?
No, sir.
For some constants bi. Okay, now suppose we have to prove that the at most one solution. For this we have to suppose phi and psi are the two solutions. Okay, suppose phi and psi are two solutions of given L of y is equal to 0, of given L of y is equal to 0. Okay, such that y of x naught is equal to alpha 1, y of x 1, sorry, x naught is equal to alpha 2 up to so on y dash, y raised to n minus 1 of x naught, which is equal to alpha n. Okay, and let L of psi, L of phi is equal to L of psi is equal to 0, because phi and psi are the two solutions of L of y, and phi of x naught which is equal to psi of x naught which is equal to alpha 1, phi dash of x naught is equal to psi dash of x naught, which is equal to alpha 2 up to so on phi raised to n minus 1 of x naught is equal to psi raised to n minus 1 of x naught, which is equal to alpha n. Why? Because phi and psi are the two solutions. Means it satisfies the given initial condition. Okay, any doubt?
No, sir.
Now define theta is equal to pi minus psi on j. Okay, now consider L of theta is equal to L of pi minus psi, which is equal to L of phi minus L of psi, because L is the linear differential operator. Okay, it implies 0 minus 0, which is equal to 0. Okay, it implies L of theta is equal to 0. Okay, any doubt up here?
No, sir.
Means theta is the solution, and also theta of x naught is equal to pi minus psi of x naught, which is equal to pi of x naught minus psi of x naught, which is equal to alpha 1 minus alpha 1, which is equal to 0. Okay, so this is theta of x naught is equal to 0. So similarly, we get theta dash of x naught is equal to theta double dash of x naught, which is equal to up to so on theta raised to n minus 1 of x naught, which is equal to 0. Okay, but we know that, but we know that theta of x naught is equal to square, okay, into bracket mod of theta of x naught plus bracket square, norm square, mod square, theta dash of mod of theta dash of x naught square plus up to so on plus this is theta raised to n minus 1 mod of x naught bracket square, okay, which is equal to 0 plus 0 plus up to so on 0, which is equal to 0, implies theta of x naught bracket square is equal to 0. Okay, since theta is the solution of L of y is equal to 0, and these functions ai of x, okay, which is less than or equal to bi for I running from 1 to n, we have this one on j, interval j, okay, by applying previous theorem. This implies norm of it of x naught is equal to 0. Okay, now applying previous theorem, we get norm of theta of x naught into e raised to minus k of x minus x naught. Okay, काय? Any problem? काय अडचण आहे का?
No, sir.
No, sir.
तेच एक्झाम्पल तेच सॉल्व करतोय आपण. ओके, थीटा ऑफ एक्स नॉट, norm of theta of x naught into e raised to k into x minus mod of x minus x naught, which implies this value is 0, this value is 0. So here 0 is less than or equal to norm of theta of x. This is for all x belongs to I, na? Sorry, all x belongs to j here. Okay, so here it is less than or equal to 0, which implies norm of theta of x is equal to 0 for all x belongs to j. It implies theta of x itself 0 for all x belongs to J. Okay, it implies that phi of x minus psi of x. What is the value of theta? Phi of x minus psi of x is equal to 0 for all x belongs to J. It implies theta of x is equal, sorry, phi of x is equal to psi of x for all x belongs to J. Okay, this shows that it shows that every initial value problem has unique solution. Problem has unique solution. Okay, any doubt?
No,
This
sir.
is very. Okay, okay. एक स्टेटमेंट बघूयात फक्त डेफिनेशन आणि थांबूया. द रिडक्शन ऑफ एनी डाऊट अप टू हिअर? काही डाऊट्स आहेत का याच्यात?
No, sir.
नेक्स्ट पॉइंट इज reduction of order of homogeneous equation. Homogeneous equation. Okay. Now suppose we have found the solution of L of y is equal to y raised to n plus a1 of x into y raised to n minus 1 plus up to so on an of x into y, which is equal to 0. Then using variation constant method, variation constant method, we can reduce L of y is equal to 0 into linear differential equation of order n. Linear differential equation of order 1 n, and obtain the second solution of the differential equation. Okay, ह्याचं प्रोसिजर कसं आहे ते आपण नेक्स्ट लेक्चरला बघूया. ओके, एनी डाऊट अप टू हिअर?
No, sir.
असतील तर विचारू शकतो तुम्ही. ओके, थांबायचं?
Oh, sir.
Yes, sir.
Okay. So in the next lecture, we see that what is the procedure of reduction of order of homogeneous equation. Okay, using the एक solution असताना दुसरं solution कसं find out करायचं? Okay, by using one solution, we can find another solution of the equation. Okay, any doubt up to here? तर तुम्ही विचारू शकता. Okay, otherwise you can leave the lecture, and thank you for the attending.
सर
बोला.
सर मला थेरम आलाय ह्याला सेमिनारसाठी.
कुठला थेरम?
लॅग्रांजेस मीन व्हॅल्यू थेरम अँड रोल्स थेरम.
ओके,
पण
हां.
सर मी बुक मध्ये हे बघितलं पण ते वेगळेच आहेत थेरम.
लँग्वेजेस थेरम आणि मीन व्हॅल्यू थेरम सोपं आहे की कंटिन्युअस आणि डिफरन्शियल असेल तर तो काय एक टँजंट वगैरे तसंच काहीतरी आहे ना, मला लक्षात नाही. रिअल अनालिसिसमध्ये आहे ना.
हा.
हां, सविता दादाचं पुस्तक आहे. त्यात घ्या, त्यात छान दिलेलं आहे. सविता
कोणतं सर?
मलिक अँड दादा. ओके, रिअल अनालिसिस.
ओके. पण सर ते एक्सप्लेन कसं करणार थेरम?
थिअरमचं त्याचं जॉमेट्रिकल इंटरप्रिटेशन आहे त्याचं. ओके, त्याचं जॉमेट्रिकल इंटरप्रिटेशन काय आहे ते नीट पहा. बिटवीन एनी टू, तुम्ही कुठे राहायला?
माळशिरस मध्ये. नातेपुते माळशिरस इकडे. हॅलो सर, आवाज नाही येत आहे.
हॅलो.
हा, आवाज नव्हता आला सर.
हो, उद्या बघून सांगितलं तर चालेल.
हो
लँग्वेजेस
सर.
थेरम आणि
पण ते
हो,
बुक कोणतं सांगितलं सर तुम्ही?
मलिक अँड अरोरा. ओके, मोठा ठोकळ्यासारखं मोठं पुस्तक आहे ते.
पण
ओके.
सर म्हणजे आता इथून म्हणजे काय अवेलेबल होत नाहीये असं
मी
बाहेर
PDF
जा.
करून तुमच्याकडे आहे का टेक्स्ट बुक हे?
नाही.
बरं, मी तुमच्याकडे खाली युनिव्हर्सिटीला असेल तर तुम्ही व्हॉट्सअपवर टाकतो. नाव काय तुमचं?
कांचन शेंडगे.
ओके, ठीक आहे, चालेल.
हा सर.
3-4
थँक
हे करून इमेज करून
थँक्यू सर.
टाक. ओके. अजून काही डाऊट्स आहेत का?
डाऊट नाही, फक्त हा थेरम कसा एक्सप्लेन करू ते काही समजत
ओके,
नाही.
ठीक आहे, चालेल चालेल. ओके, थँक्यू. यू कॅन लिव्ह नाऊ.
हा. हो सर.